welcome to the next video. This will be lesson 1 of unit 1. We're going to be covering the real number system. Now this is going to be an abstract concept because you may never have thought about numbers quite this deeply. What we work with in algebra is the real number system, okay? And there's kind of a Russian nesting doll of numbers, where the biggest doll is real numbers, and then it proceeds to contain smaller and smaller groups. And I'm going to list these out for you so that you can start to understand what each number is. Then at the end of the video, I'm going to put up 5 numbers. I'm going to ask you to classify what kind of number they are and what groups they fit in. All right, firstly, we have what is called natural numbers. And I'm going to use some abbreviation here. So we're going to call it natural numbers. I'm going to use some abbreviation. So the natural numbers are what you would consider counting numbers. If you had a stack of pencils in front of you, you would count them with natural numbers. So this is not going to include 0. You're going to count 1, 2. So you're going to count 1, 2, 3, 4, and so on, stretching on in the positive direction. Now, I'm actually going to erase those 3 dots because you're not going to stretch on for an infinite amount of time. You can't count an infinite amount of time, or pencils. So with the natural numbers, a key property is that there is no 0 and there are no negative numbers. These are the natural numbers or the counting numbers. Okay, now the next class, we're going to class of numbers or set of numbers, whole numbers. Okay, whole numbers now include 0 and stretch on for infinity towards positive infinity. So whole numbers is the whole set greater than 0. So we could say all real numbers greater than 0. All right. So that's whole numbers. Now we're going to move on to integers. Integers. Remember, we're classifying numbers here. Integers. What are integers? Now, integers are going to stretch towards positive on the number line towards infinity and towards negative infinity. So let's just go ahead and draw a number line. And we're going to put 0 in the middle. Alright, so the integers include everything stretching on towards going in the left direction, to put it in a visual sense for you, everything going in the left direction is going to be an integer, and everything going in the right direction is an integer, and everything in between is an integer. Now, this includes those numbers in between. Well, actually, it doesn't include the numbers in between. It's all the whole numbers stretching from one direction to the next. And the reason that is because we have another class of numbers. And that class is rational numbers. Okay? And rational numbers are numbers that can be expressed as a fraction or numbers with a terminating decimal, such as 0.25. This also includes numbers with a repeating decimal, which can be written as so, but it's exact fractions or terminating decimals or repeating decimals. So now you're starting to see how this works, right? Because as I've gone down levels, level 2 contains everything. Level 2 here contains everything within level 1 and some more. And then when we go to level 3, it contains everything in level 2 and some more, all the negative numbers. And now when we go on to rational numbers, it contains everything within level 3 and more. And all of this is contained within the real number system. So now let me introduce you to one more set of numbers, and that is irrational numbers. Okay. Irrational numbers are numbers which have decimals which repeat on for infinity, or in other words, do not terminate. So, for example, a famous example, we have pi. Pi is an irrational number. Okay, for another example, the square root of 2 is an irrational number. If you punch in the square root of 2 on a calculator, you are going to get a number which will repeat on forever and ever. It just keeps repeating. You can't get the precise enough. The calculator shows one thing, but in truth, this decimal just keeps going on and on to more precise measurements, just like pi. Okay, so again, all of the irrational numbers are contained within the real number system. So irrationals are a little bit of a special case because they're not perfectly defined. So we know that like pi is 3.14159263 on and on and on, and we know that means it's roughly in here somewhere, but we can never know exactly where. So irrational numbers are contained in the real number system, And in a way, they're contained in the integers and the rational number, in the integers, but they're kind of their own class of things. All right, and what we can create. So now, what we're going to do, now that you know this, is I'm going to explain how each of the sets of numbers fit within one another. So I'm going to draw a nesting box. All right, and in the great big box here is all the real numbers. Everything that we work with is contained within this great big box. And then there's a smaller box nested within the real numbers that contain all of the rational numbers. Rational numbers. Rational numbers. All right. Now that I'm mentioning rational numbers, it's important to note that there's a separate box over here contained within the reals, but not contained within the next nest, which is the irrational. 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 Okay? So that's off on the side here from real. Now the next one we have contained within all of the rational numbers is you have the integers. Now contained within that box contained within all of the integers is all of the whole numbers. So you see how each fits into the next layer. All of the whole numbers are contained with integers, but integers have more than whole numbers. Then we have another box which contains all of the natural numbers. All right. So as you can see, all of the everything is within real numbers. The rationals are part of the real, but not part of the integers. The irrationals and the rationals are completely separate. The integers are contained within the whole number. The whole numbers are contained within the integers, and integers are contained within rationals. But integers have things that whole numbers don't. So as you go up the nest, you're adding new numbers to each set. The natural numbers, counting numbers, 1, 2, 3, 4. Whole numbers are 0, 1, 2, 3, 4, stretching on for infinity. The integers go into the negative. The rationals are fractions, things in between integers, like -1/2, 2.5, so on. And now all of that's contained within the real numbers. So, time to move on, and I'm going to give you some practice here. I've listed, let me just erase this. I've listed a set of numbers here, 5 of them. I want you to look at each one and classify it into each group that you're aware of it being a part of. And after you finish that, I'll do it myself. Okay, great. Now we're looking at 5. All right, as all numbers are, This is a part of the real numbers. It is a rational number. Rational. It is also part of the integers. And it is part of the whole numbers. And finally, it is part of the natural numbers. All right, let me go ahead and open up some space over here. And try here. All right, now let's look at -8 here. -8 is part of the real numbers. Real numbers. It is a rational number. Rational. It is part of the integers. Yet it is not part of the what you would call whole numbers or natural numbers. Whole numbers move in the positive direction. So now we come to 1/3. It again, as all numbers are, is part of the real. It is a rational number because it is a terminating fraction or complete fraction. Any fraction is going to be a rational number. But it's not part of the integers, right? Integers are only whole numbers between -infinity and +infinity. Now let's move on to 0, part of the real. And it is indeed part of the whole numbers, but it's not part of the natural numbers. Let me back up. It is real. It is rational. It is an integer. And it is whole. Yet it is not a natural number. And finally, we're looking at pi here. Pi is a real number, but pi is an irrational number. Well, remember, irrational is off on its own little box. And that's it for that. So this was an introduction to the real number system. There's a lot of terminology here, but it's important that you know this stuff and familiarize yourself with it. Thank you for joining me. See you next time.